Type 1 and Type 2 drivers. In the previous lesson, we've discussed about Java Database Connectivity, or JDBC, and its advantages. Now we will discuss the types of JDBC drivers. Let's start with Type 1, JDBC-ODBC Bridge Driver. A JDBC-ODBC bridge provides a JDBC API access through one or more ODBC drivers. Translates all JDBC calls into ODBC, Open Database Connectivity, calls, and sends them to the ODBC driver. This driver is also known as Type 1 driver. In this type, we have to load the ODBC native code. In many cases, it will be a native database client code on each client machine. This type of driver is appropriate for experimental use and for situations in which no other driver is available. Type 1 driver is the simplest of all drivers, but it's platform specific, i.e. only to the Microsoft platform. Here is a typical JDBC-ODBC bridge environment. Just to recall the steps of using JDBC-ODBC driver to connect to a database. As we discussed earlier, the request from the application goes to Driver Manager and then to the Type 1, i.e. the JDBC-ODBC bridge driver, then to the ODBC driver, and communicates with the database through the vendor database library APIs. Let's look at benefits and drawbacks of the Type 1 driver. Benefits. This type of driver allows access to any database, since the database's ODBC drivers are already available. Type 1 drivers may be useful for the companies that have already installed an ODBC driver on client machines. Drawbacks. The performance is degraded because of two levels of accesses, i.e. the JDBC call goes through the bridge to the ODBC driver, then to the native database connectivity interface. The result comes back through the reverse process, so Type 1 drivers may not be suitable for large-scale applications. The ODBC driver and native connectivity interface must be installed already on the client machine. So we can't use Java applets in an intranet environment because of the deployment problems of traditional applications. Type 2, Native API, partly Java driver. A native API, partly Java driver, is also called Type 2 driver. It converts JDBC calls into database-specific calls for databases such as SQL Server, Informix, Oracle, and Sybase. This type of driver communicates directly with the database server, so it requires some binary code present on the client machine. However, the Type 2 driver provides more functionality and performance than the Type 1 driver. Now we will discuss how we can get the database connection using Type 2 driver. Here is the flow of request in this environment. The request from the application goes to a Driver Manager and then to the Type 2 driver, and then it accesses the vendor database library APIs to communicate with the database. Let us see the benefits and drawbacks of Type 2 driver. Benefits. Type 2 drivers typically offer significantly better performance than JDBC-ODBC bridge driver because it does not have the overhead of the additional ODBC function calls. Drawbacks. The vendor database library needs to be loaded on each client machine, so Type 2 drivers cannot be used for the Internet. Here we also can't use Java applet because applets cannot load the native code. Type 2 drivers provide lower performance than Type 3 and Type 4 drivers. If you want to know more information about the JDBC-ODBC bridge drivers, refer to this link. Type 3 and Type 4 drivers. Here we will discuss the remaining types of drivers. They are Type 3 and Type 4. These drivers are purely Java technology-enabled drivers. Applications and applets can access database via the JDBC API using pure Java technology-based drivers. Type 3, JDBC-Net Pure Java Driver. A JDBC-Net Pure Java driver, also known as Type 3 driver, translate JDBC API calls into a database-independent net protocol, which is then translated to a database-specific protocol by a middleware server. The middleware server provides connectivity for Java technology-based clients to access many different databases. All vendors of this solution will provide suitable products for intranet use. Also, the middleware provides additional requirements for security, access through firewalls, and etc. to support Internet access. Several vendors are adding JDBC technology-based drivers to their existing database middleware products. Generally, the Type 3 JDBC drivers are the most flexible JDBC solution because they don't require any native binary code on the client. Here is the diagrammatic illustration of usage of the Type 3 driver. Here we should recall the above steps and see the data flow. The request from the application goes to a driver manager and then to the Type 3 driver, and then it goes to the middleware server, and finally it communicates with the particular database. Let us see the advantages and disadvantages. Advantages. There is no need for the vendor database library on the client machine because the communication between client and the middleware server is database independent. Use of the middleware server provides typical middleware services like caching, load balancing, logging, and auditing, etc. We can use it in Internet because there's no need for client-side software. There is a single driver that can handle any database at client-side. Disadvantages. It requires database-specific coding to be done in the middle tier. Here we added an extra layer that results in a time delay, but this can be overcome by providing efficient middleware services. Type 4, Native Protocol Pure Java Driver. A native protocol pure Java driver is also known as Type 4 driver, and it converts JDBC calls directly into the vendor-specific database protocol. This allows a direct call from the client machine to the DBMS server, and it is a practical solution for intranet access. As many of these protocols are proprietary, the database vendors themselves will be the primary source for this type of driver. Here the protocol conversion is present in the client side, but in Type 3 driver it is in the middle tier. Like Type 3 drivers, the Type 4 drivers are also written completely in Java, so it is also platform independent. This driver is installed inside the Java virtual machine of the client. As the database protocol is vendor-specific, separate drivers, usually vendor-supplied, need to be used to connect to the database. For example, Data Direct Technologies provide Type 4 driver for various databases such as MS SQL Server, AS400, and DB2. Sun encourages using Type 4 drivers in our applications. Here is the illustration of the usage of the Type 4 driver. The request from the application goes to Driver Manager, then to the Type 4 driver, and then it communicates with the database. I think now you've got a clear idea. Let us see the advantages and disadvantages of Type 4 driver. Advantages. It provides better performance over the Type 1 and 2 drivers because it does not have the overhead of conversion of calls into ODBC or database-specific API calls or to any middleware layer. Unlike the Type 1 and 2 drivers, it does not need any associated software. Thus, the performance is considerably improved. Disadvantage: at client side, a separate driver is needed for each database. This type of driver may not be suitable for some applications if the underlying protocol does not handle issues such as security and proper network connectivity. Well, let's move on now to discuss about the driver manager in the next lesson.